Good evening and welcome to this interactive session. So today I had planned for finishing the rest of the problems in traffic engineering and also take up a little bit of open channel flow. Before that, we have some questions in the forum, so let us take them one by one. As I said, this one it is not right now. I am not prepared for this principal component analysis, so we'll take this question 25 and 34 right now. So this is from linear algebra and this is from calculus. Let us solve them. So question 25, this reads, there are two eigenvalues of a 3 cross 3 real matrix. X are 1 plus I and 2. What is the determinant of the matrix? So this appears a little complicated, but it's actually very simple. It is. So we have a real matrix which is 3 cross 3. So what do we know if it is a 3 cross 3 matrix? It has 3 eigenvalues and 3 eigenvectors. Okay, hoping that it is diagonalizable. So assuming it is diagonalizable. If it is diagonalizable, we'll have 3 eigenvalues and 3 independent eigenvectors corresponding to them. So this includes 3 includes repeated also. So this is the basic. So what are eigenvalues and eigenvectors? You know that eigenvalue is something that sorry. So the set of the vectors, the 3 cross 1 or n cross 1 vectors that satisfy. Let's take this equation as star that satisfy this equation star for any real parameter, not necessarily real, for any scalar. It can be complex as well. Lambda are called eigenvectors. And these scalars lambda, which can be complex in general or real, are eigenvalues. So this we know. So this is one thing. This is the definition of an eigenvalue problem. So eigenvalue problem is to find the vectors x that satisfy ax equal to lambda x for any scalar lambda, which are called the eigenvalues, and x is called the eigenvectors, and x should not be equal to 0. So find the vectors x that are not equal to 0. So this is fine. Ax equal to lambda x is what we need to solve. Now they're asking us to find out the determinant of A. So does any of you know the relationship between the eigenvalues and the determinant of a matrix? So they're asked to find out the determinant of A. Any guess?
Product of the eigenvalues is equal to the determinant.
That is correct. So determinant is equal to the product of eigenvalues. Can you prove it? Okay, so the proof is it is very simple. For example, take this case where we don't need to consider n cross 1. Let us just take 3 cross 3. So A is a 3 cross 3 matrix. So which means that, and assuming that it is diagonalizable, it's just a technicality. Diagonalizable basically means that we have as many independent eigenvectors as there are eigenvalues, including repeated values. So if you have a 3 cross 3 matrix, then you can find at least 3 independent eigenvectors which obey Ax1 equal to lambda 1 x1, Ax2 is equal to lambda 2 x2, and Ax3 is equal to lambda 3 x3. Now what we can do, we can write it in a form. If you arrange the vectors like this, right? So this is 3 cross 3. This is 3 cross 1. This is 3 cross 1. This is 3 cross 1. This is equal to what? This will be lambda 1 x1, lambda 2 x2, lambda 3 x3. So this is 3 cross 1, 3 cross 1, 3 cross 1. So this is totally 3 cross 3. And this is again, so each of the columns is one vector of with 3 elements. So this is 3 cross 3. Now with some, so this right hand side you can also write it as x1, x2, x3 multiplied by the diagonal matrix lambda1, lambda2, lambda3 with zeros everywhere else. You can check. So you multiply using the usual uh, matrix multiplication rule. So you uh, take the first column. So you do the row by column thing, right? So this, if you write it as x11, x12, x13, then you do the multiplication. This is what you will get. So this is the matrix of eigenvectors. Let us call it X. So this is, so the eigenvalue problem is Ax is equal to X into, this is the diagonal vector. We can also take this X to the other side. So we get A is equal to X lambda X inverse. Now what we have done is we have written A as a product of three matrices. Now what we can write about determinant of A? Determinant of A is, you know, the determinant of product of three matrices is product of the three determinants. Determinant of X, determinant of lambda, determinant of X inverse. Now determinant of X inverse is 1 by determinant of X. So these two will cancel each other. So it is nothing but determinant of lambda. What is the determinant of a diagonal matrix? Is lambda 1 into lambda 2 into lambda 3. So that is basically the proof. So determinant of A is the product of its eigenvalues. Next, further, we are given that in the question, A is a real matrix. So A is it's a 3 cross 3 real matrix. So if you compute the determinant of A, will it be complex? No, it is not possible. It also has to belong to real numbers. So just note this. This is one point. We are given a real matrix, so its determinant is real. And what are its eigenvalues? Eigenvalues are, so lambda 1 is equal to 1 plus I. Lambda 2 is equal to, if it is 2. And what is lambda 3? So, uh, so yeah, this is okay. This is the question we have. Now, how do we determine the eigenvalue? So we know the eigenvalue problem is Ax equal to lambda x, where x is eigenvector and lambda is the eigenvalue. You can take it to the other side, so you get Ax minus lambda x equal to 0. So this you can write as Ax minus lambda into identity times x equal to 0. So this is matrix product is distributive. So you can take A minus lambda I acting on x equal to 0. So this is of the form, this is some matrix. This is some unknown, right? X is an unknown is equal to 0. This is some. So this is of the form some bx equal to 0. It's like a system of linear equations. So this has a x equal to 0 is a solution. If you're looking for x not equal to 0, which is an eigenvector, then B must be singular. So what is a singular matrix? Then the determinant of A minus lambda I should be equal to 0. You know that this is what is called the characteristic equation of the matrix. And what are the solutions of the characteristic equation? The solutions of the characteristic equation are the roots of the are the eigenvalues. Sorry, the roots of the characteristic polynomial or the solution of the characteristic equation is the are the eigenvalues. So what is the characteristic equation if lambda 1, lambda 2, and lambda 3 are if lambda 1, lambda 2, and lambda 3 are the eigenvalues? You know that from fundamental theorem of algebra, the characteristic equation is this. It should be a cubic polynomial. And if lambda 1, lambda 2, lambda 3 are the roots, this is the only cubic polynomial with lambda 1, lambda 2, and lambda 3 as the roots. This you agree?
Yes, sir.
Yeah. So here comes the important part. So now you can suppose you are given that lambda 2 is equal to 2, which is real. Let us take this out. Lambda minus lambda 2 multiplied by lambda square minus lambda 1 plus lambda 3 plus into lambda plus lambda 1 lambda 3 is equal to 0. So I have just rearranged the, I have taken this lambda minus lambda 2 out and I have taken the product of the other two. Now this is real. Lambda minus lambda 2 is equal to 0. So let us just look at this part. Okay. So this lambda 2 is real. So lambda equal to lambda 2 is one solution. Let us only look at this part. So we have from the characteristic equation, we have lambda minus lambda 1 plus lambda 3 into lambda plus lambda 1 lambda 3 equal to 0. Now this is a part of the characteristic equation. So this comes from the coefficient of the matrix. Has to be real. And similarly, this also has to be real. Right? Because where do they come from? They come from the entities of the matrix. So A minus lambda is some matrix, and these come from the entities of the matrix. So lambda 1 is known. Lambda 1 is known and it is complex. And what are the roots of this equation? Roots of this is a quadratic equation with real coefficients. So it's a quadratic equation with real coefficients. What are its roots? It will be minus b plus or minus root of b squared minus 4ac by 2a. Right? So lambda 1, lambda 3 will be this. And it is a quadratic equation with real coefficients, and we know that one of the roots is complex. So if one of the roots is complex, it means b squared minus 4ac is less than 0. So what are the roots now? So lambda 1 is equal to minus b plus I times root of b squared minus 4ac is less than 0. So an I comes out. If I take minus 1 out, we get 4ac minus b squared by 2a. And lambda 2 will be its complex conjugate, which is minus b minus I root of 4ac minus b squared by 2a. So basically lambda 2 is, lambda 3. 2 we already know. So lambda 3 is the complex conjugate of lambda 1. Right? So this is another fundamental result in mathematics. So complex roots always occur in pairs. So complex roots of a polynomial with real coefficients always occur of a polynomial with real coefficients always occur in pairs. So this is something you need to know. So that's all. We have solved the problem. So one thing is this I have shown that the determinant of a matrix is the product of its eigenvalues. And here is the proof. So proof is not important from gate point of view, but this will help you solve certain other problems in matrix algebra. And for a real matrix, it is a real matrix. They mentioned particularly in the question that it's a real matrix. So all its entries are real. And if all its entries are real, the coefficients of the characteristic equation, which come from the entries of the real matrix, they should also be real. Therefore, this is a real quadratic equation with real coefficients. And the only way it can have complex roots is they occur in pairs. So we are already given that lambda 1 is equal to 1 plus I. So what is lambda 3? It is lambda 1 conjugate. So it should be 1 minus I. 1 minus I. So what is determinant of A? It is lambda 1 multiplied by lambda 2 multiplied by lambda 3. So it is 1 plus I into 2 into 1 minus I. So 1 plus I into 1 minus I is 1 minus I square into 2. What is 1 minus I square? It is 1 minus minus 1 into 2. So the correct answer to the question is 4. So that's how it is. So basically to solve this problem, you need to know two results. Determinant is the product of the eigenvalues, and complex roots of a polynomial always occur in pairs. You cannot have a polynomial where 1 plus I is the root and 1 minus I is not. You cannot have a polynomial with real coefficients for which 1 plus I is a root and 1 minus I is not a root. So if you factor out the other roots, you get a quadratic equation. And whenever you have a quadratic equation with real coefficients, you need to have two roots. And those two roots will be complex conjugates of each other. Yeah, so the answer to this question is 4. So 1 plus I into 1 minus I is 2. And multiplied by 2 is 4. So this you can remember. This you can kind of remember. So is that okay? Does it solve your doubt?
Yes, sir.
So coming to the next question. The function, you're given a function f of x equal to 1 plus 2x plus. So just a minute. So this Shivani Verma is like, is it one of you or is it somebody else?
It is me only.
Oh, okay, okay, fine. That is fine. Just I was just thinking it shouldn't be somebody else who is not in the meeting. Right? Fine. So function f of x is given as this. So there is an interesting question. Let us solve this. We are given f of x is 1 plus 2x plus 3x squared up to 2026 x power 25. 2025. Now they are given many options. So a lot of those options have to deal with some local minimum, local maximum, global minimum, global maximum. So that is okay. So we can see first, let us rule out the wrong options. One of the questions, the last option is f of x is not continuous. So that's obviously wrong. F of x is a polynomial. So I can see f of x is a polynomial of degree 2025. So, and then polynomials are infinitely differentiable. You can differentiate them any number of times. Right? And if a function is differentiable, obviously it is continuous. So f of x is continuous. Therefore, option D is wrong. D is wrong. That is okay. Then the other options are a little. So look at option C. F of x does not have a global minimum. That we need to look. That we need to see. That is not easy. Option B says f of x has a global maximum. So can we check that? Now you see that when x is greater than 0, they haven't said what is the range of x, right? So when nothing is said, you can take domain as of f of x as the entire real line. So x is somewhere between infinity. It cannot be equal. Right? Now we'll consider x greater than 0. So if x is greater than 0, you can see that f of x is equal to 1 plus 2x plus 3x squared up to 2026 power x power 25. It increases, it's a polynomial. When x is greater than 0, all the coefficients are positive. All coefficients are positive. And what about its slope? So f dash of x is 2 plus 6x plus what will be the next term? 4x cubed. So it is 12x squared plus up to 2026 multiplied by 2025 x power 2024. So the slope of f dash of x, the slope of f of x is just f dash of x. Whenever x is greater than 0, f dash of x is greater than 0. What does this mean? Any idea? So f dash of x is greater than 0 for all x greater than 0, which means f of x is, yes, strictly increasing function on x greater than 0. So if a function is strictly increasing, x less than 0, we don't know anything, but we know f of x is 1 plus something. So when x is equal to 0, it is 1. And beyond that, the slope is never equal to 0 or less than 0. So the slope of the function is always positive, which means, and what is the slope at x equal to 0? It is 2. So it starts off at some slope. It's only increasing. Therefore, if a function is strictly increasing for all x, this is x. This is f of x. So a function f of x is strictly increasing for all positive values of x, which means as x tends to infinity, what will happen? F of x tends to infinity. So you can see it is unboundedly growing. So when x reaches infinity, the function is infinity. Therefore, it does not have a global maximum. Infinity is not considered a maximum, so it does not have a global maximum. So option B is correct. Sorry, not this. Option B is wrong. Sorry, f of x has a global maximum. That option is wrong. F of x cannot have a global maximum. So if you see option B is wrong, then option C is correct. F of x does not have a globe. Sorry. F of x has a global maximum. That option is wrong. Option B is wrong. Option D is wrong. Option C we need to see. So either of option C or option A is correct. So I don't know if it is a single correct or multiple correct question. So in either case, option B and option D are wrong. And either option A is correct or option C is correct. So I think it is a single correct type question only. So the next thing to look at is whether f of x has a global minimum or not. So let us look at it. Again, look at f dash of x. So f dash of x is, we have this 2 plus 6x plus 12x square plus something up to x power 2025. And then consider, so f of x is 1 plus 2x. So you can write f of, now again f of 0 is equal to 1. And it is differentiable everywhere. So the next thing to consider is f of x as x tends to minus infinity, right? Now again, f dash of x, if you see, so if you consider x less than 0, f dash of x is a polynomial with all positive coefficients. And so f dash of x is, you can take x equal to minus y. So you can take 2 minus, you'll get 6y plus 12y square and so on. Where this is something always positive. So this is strictly positive. Because x is equal to minus y, we're taking x less than 0, so y is positive. So this quantity within the bracket is always positive. 2 is positive. So f dash of x can be 0. So this is a positive value. We have positive values of y, which f dash of x equal to 0 is possible. And what about f dash of x less than 0? That is also possible. for x less than 0. So with respect to local maxima and local minima, you can have something. But what about the global minimum? Now consider f of x, f dash of x, as x is very, very large, and x is less than 0, and it is much extending to minus infinity. So as x tends to minus infinity, it means y tends to infinity, and this polynomial is unbounded. So this is a polynomial with all positive coefficients. So this is a very large positive value. So it will be, say x is minus 1000. In that case, y will be 1000. So this is like 6000 plus 12 into 1000 square and so on. So this is a very large negative value. Therefore, f dash of x is a very large negative value when x is less than 0. And therefore, f of x is, but it is not monotonic. That we need to take care. So it is not monotonic. So there is something you need to do here. So you have f of x as 1 plus 2x plus 3x square up to something. Let us consider integral of f of x dx, just the indefinite integral. So we get x plus x square plus x cube and so on up to x power 2026. What is the sum of this series? Right, let us call this sum as s of x is equal to summation x power n going from 1 to 2026. And what is x s of x? It is summation m going from 2 to 2027 x power m. So this is nothing but m going from 1 to 2026 x power m plus x power 2027 minus x. That's what it is. So this is nothing but s of x plus. So just rearrange, you get x minus 1 into s of x is equal to x power 2027 minus x. So s of x is x power 2027 minus x divided by x minus 1. Now, so this we have got instead of a polynomial, we have some rational form. The next step is you just find out so f of x is s dash of x. And if we are looking at the local maxima, local minimum, then f dash of x is s double dash of x. So you have a rational function, you can differentiate and you can get all the local quantities. And you can see that the local maxima and local minima are bounded. So the function is continuous. F of x is, as I said, it is infinitely differentiable. Which means it is bounded on minus infinity to infinity, right? If a function is taking infinite value somewhere in between, then at that point it is not continuous. It cannot be continuous. So since the function is differentiable, its derivative is bounded on minus infinity to infinity. Only at the extreme, only at the x equal to infinity or x equal to minus infinity, it takes up very big values. Now, there may be values where f dash of x is equal to 0 or less than 0 for x less than 0. But that is not a problem because even if it is taking such values, even if f dash of x is less than 0, f of x is bounded in those regions. So for all values, so for very large negative values, for x tending to minus infinity, f of x tends to minus infinity as well. Therefore, there is no global minimum. So, okay, I have taken multiple slides. So the first thing you need to look at is it is a polynomial. So it is continuous. Continuous and differentiable everywhere. Therefore, the last option is wrong. Second thing, it is a polynomial with positive coefficients. positive coefficients, and we saw that its derivative, since it is a polynomial with positive coefficients, derivative greater than 0 whenever x is greater than 0. So since the derivative is always positive, it is strictly increasing. And since it is strictly increasing, as x tends to infinity, f of x tends to infinity as well. Therefore, there is no global maximum. Then we are investigating what is happening when x is less than 0. So when x is less than 0, it is not uh, when x is less than 0, it is not strictly increasing, right? Because you had this f dash of x in this form, 6y plus something. So f dash of x can be 0, f dash of x less than 0, it is possible. So when x is negative, you had something like this. So it is not strictly increasing. However, since the function is continuous and differentiable, the value of f dash of x is bounded. So anywhere here, the function takes a bounded value. From that bounded value can be positive, but from that bounded value, f dash of x is always greater than 0. So as x tends to infinity, x tends to minus infinity. So if you make the substitution, x is equal to minus y, and as x tends to minus infinity implies y tends to infinity, there f dash of y is always greater than 0. Therefore, as x tends to minus infinity, f of x tends to minus infinity as well. Therefore, it has no global minimum also. The minimum value is minus infinity, the maximum value is infinity, so it doesn't have a global maximum or a global minimum. So the correct answer to this question is f of x does not have a global minimum, option C. So another short, so this is a systematic way to analyze, but if you're given a polynomial, you can directly you'll directly know that it is of this form. A polynomial, it usually starts at minus infinity. Between 0 to 1 or minus 1 to 1, it has some oscillations and it goes to infinity again. So this is how most polynomials behave. Sorry, a polynomial with constant coefficients. Okay, don't rely on shortcuts. You just look at examine this way. It is continuous. Look at the coefficients. They are all positive with positive derivatives. So it is strictly increasing. And in between, there may be oscillations. There will be local maxima and local minimum. And how to find those local maximum, local minimum? You do this analysis. So in this case, you can write s of x as this, f of x as derivative of this function. You can find the local maximum, local minimum, but you're assured that those are bounded values. They don't go up to infinity. Therefore, the minimum value is some bounded value minus a continuously decreasing function. So the least value will be minus infinity, which is achieved at x equal to minus infinity. Therefore, it doesn't have a global minimum. So the correct answer is option C. So I hope it's clear. Is that okay?
What's the meaning of f dash x is bounded?
Bounded means it is not. So f dash x is bounded means suppose I take say f of x equal to x square 1. The least value it can take is 0, and the maximum value it takes is 1. So f of x is less than or equal to 1 or minus 1 to 1. If we have a statement like this, then so if f of x is less than or equal to some m on a certain interval, then f of x is bounded. So if I say f dash of x is bounded, it means you just put a dash everywhere. That is what it means. On the other hand, if I take f of x is equal to cot x, that is not bounded at. So if you take f of x equal to cot x on minus 1 to 1. So as x tends to 0, f of x tends to infinity or minus infinity, depending on which side you approach it from. So this function is not, it is unbounded. So this, say, let us take it as g. G of x is unbounded. Or minus 1 to 1. No need of cot x. You can just take f of x is 1 by x or 1 by x square. So, or h of x. So h of 0 approaches infinity. So h is unbounded on this interval. Here, when I say f dash of x is bounded, I'm considering an interval near 0. So very far from 0, for very large negative values of x, we see that it approaches minus infinity. But somewhere in between, you don't know, right? It can be, if it approaches some value, very large value, it will be subtracted from that. So we need to look at it in an interval, in a finite interval, which is a subset of the real line. There it is always bounded, except at the values minus infinity and infinity. For any real value, any real interval you're taking, which is a subset of the real line, f of x is bounded, f dash of x is bounded. That's what I mean. Bounded means it doesn't go to infinity, basically. Is that okay? So if you're able, yes,
It's okay.
yeah, if you're able to find a constant such that, uh, yeah, the definition of boundedness, mathematical definition of boundedness is if you're able to find a positive constant such that the modulus of a function is less than or equal to m for all x belonging to some interval I, then f of x is bounded on that interval I. And for this function, I'm taking f dash of x. F dash of x is f dash of x over any real interval because it's having only positive coefficients. It's a polynomial, and you take any real interval which is not a interval doesn't include the infinity. So on any real interval, which is a subset of R, it is bounded. It doesn't take infinite values. So that is the idea. Okay, so as I said, this question, maybe I'll look at it in the next. I'll first have to study principal component analysis. That is not something I've gone through. I'll go through it and then I'll try to answer in the next session. Yeah, because next one is also focused on probability. You can do that. So getting back to our traffic analysis. So we were looking at yeah, so we were looking at various traffic flow characteristics. Sorry, not too clever. Yes. Just a minute, I will find it. Okay, I have lost the written notes. It got deleted, but so basically we were looking at the traffic flow parameters. So we saw uh, there are three important things. And remember this matrix always, you have macroscopic characteristics and you have microscopic characteristics. And the three fundamental properties are speed, density, and flow rate. So flow rate is something measured in vehicles per hour. Speed, it is meters per second or whatever. Density is the number of vehicles in a given stretch of the road, something like vehicles per kilometer. So corresponding macroscopic parameters deal with the entire flow, multiple vehicles taken at a time. Microscopic look at a given vehicle at a time. So with respect to speed, macroscopic are time average speed and spatially average speed. And microscopic is the spot speeds. So we solved this problem. So where, okay. This is fine. Okay, we didn't solve this. Okay, fine, fine. So we looked at what is a space-time diagram. So space-time diagram is something that plots the position of every vehicle as a function of time. So each of the lines here represent one vehicle, and there are multiple lines which represent other vehicles. So the slope of the space-time diagram of a given vehicle at a given x and t is called the spot speed. So spot speeds are for a given vehicle, so it is a function of x and t. You can call it v of x and t. V is the usual dx by dt. So dx by dt is a function of x and t of the vehicle. So that is the spot speed. What is the time average speed? So time average speed is a spatial quantity. So time average speed in order to compute the time average speed, suppose we have the highway. You stand at a point, you put an observer here. There are many vehicles passing through. So you fix the observer at a given x equal to x naught. And you take the time interval t1 to t2. So in this interval, you look at all the vehicles passing through this point x equal to x naught. Now, if you take a time space diagram, x of t, x versus t, you'll have many vehicles like this passing through that. Now you fix x equal to x naught, and you fix time from say t1 to t2. What are the vehicles passing through x in this interval? We have one vehicle here, and we have another vehicle here. So the time average speed Vt of a given point x in the highway is defined as summation of all vehicles passing between t1 and t2. So I equal to 1 to n. The spot speeds of all such vehicles divided by n. This is nothing but the arithmetic mean. What is the space average speed? Let us take the next. Very simple. These are simple concepts. So these two are conjugate quantities. So again, to consider a highway. Now, instead of putting an observer at a point, you take at a given instant of time. So photograph. So there are many vehicles passing on the highway. So you just take a photograph of the highway at t is equal to t naught. So just take a snapshot of the highway at t equal to t naught and consider a given stretch of the highway. Say this is x equal to x1 to x equal to x2. Now in the time space diagram, it means you're considering something like this. You take x equal to x1 and x equal to x2. When at a given snapshot in time, t is equal to t naught. So at this instant of time, how many vehicles are there between x equal to x1 and x equal to x2? There is one vehicle here and there is another vehicle here. So suppose this vehicle has a speed v1 and this vehicle has a speed v2. Space average speed is the at a given time t is the total distance traveled by the vehicles divided by total time. Right? So suppose these vehicles are traveling at a constant v. What is the total distance that is traveled? It is this. So the first vehicle in a given time, this first vehicle will travel the entire stretch, say x2, suppose x equal to x2 minus x1. The total distance x, the time taken for vehicle 1, and let us call this vehicle 2. The time taken for vehicle 1 to cover a distance x is x by v1. That is t1. And what is the time taken for vehicle 2? It is t2, which is x by v2. So what is the space mean speed? So the space mean speed is the total distance. So the vehicle 1 travels x, vehicle 2 travels x divided by x by v1 plus x by v2. So this is nothing but, so I can cancel out x. So it is nothing but 2 by 1 by v1 plus 1 by v2, which is nothing but the harmonic mean. If you recollect your class 12, you have studied three types of means, arithmetic mean, geometric mean, and harmonic mean. And this is the harmonic mean. So if you have n number of vehicles, the space mean speed is given as as a function of time. The space mean speed as a function of time. Is the number of vehicles in the road stretch at any given instant. You take x equal to x1 to x equal to x2. In that given road stretch, the number of vehicles in that divided by. So in place of t, you have n, and in this, you have a summation 1 by vi. I going from 1 to. So time means speed is that basic. So this looks at all vehicles in a given stretch, and this looks at all vehicles passing through a given point in a given time interval. This is a space interval. This is a time interval. So these are the time means speeds and space means speeds. Density, as I said, to take this road stretch, count the number of vehicles. Suppose n number of vehicles are there at a time t, then the density is nt by x, denoted by k. So if you have n number of vehicles at a given time, divided, sorry, n number of vehicles in the given stretch x divided by x, and this is a function of time. At different points in time, you can have different densities. The corresponding microscopic parameter is. So this you are considering an average value. You're considering all the vehicles divided by the distance. With respect to every vehicle, what is the spatial parameter? It is the distance between two successive vehicles. That is called the distance headway. So consider two successive vehicles. Suppose the corresponding points of the two successive vehicles are separated by a distance si. We know the summation of I equal to 1 to n. If you consider all the vehicles in the given stretch, the sum has to be equal to the length of the stretch itself, because that is all the vehicles in the stretch. So that is equal to x. And you have one, if you divide it by n, sorry, that is equal to x. So let this be. And now you consider what is n by x, it is the density, right? The number of vehicles in the given stretch divided by the length of the stretch itself. Further, what is x? You can write it as summation si from I equal to 1 to nx. So this is again, it is nothing but 1 by average of average spacing. So this is the relationship between the distance headway si and the density. So this is something that depends on time. And what about the flow rate? Flow rate is the number of vehicles passing a given point. So again, you consider a highway. Fix a given point x equal to x naught. Look at all the vehicles passing through that point. So flow rate is nothing but the number of vehicles passing through that point in a given interval divided by the time interval. So consider t1 less than, you take this interval, you count how many vehicles are passing through the given point in that interval, and then divide by the length of the interval. So this is vehicles per hour or per day, whatever it is. So this is how you define flow rate, and similar to what we did in you take the time difference between two successive vehicles. Between the arrivals, right? First, again, suppose these are the different vehicles. You fix the given x. So this is vehicle 1, this is vehicle 2, this is vehicle 3. And suppose the time of observation is from t1 to t2. And let this total distance be t, total time interval be t. How many vehicles are passed? 1, 2, and 3. So 3 vehicles. Flow rate is the number of vehicles in the time interval t divided by the length of the time interval t. And the gap, what is time headway? Time headway is a time difference between successive arrivals. So for this vehicles, this is the headway h1. For this vehicle, it is the headway H2. And if you sum all the headways over all the vehicles that are arriving in the time interval t, you should get the total interval t. Now divide by n on both sides, so you get h average is equal to t by n. But what is t by n? It is 1 by flow rate. Therefore, the flow rate is nothing but the number of 1 by the average time headway. So let us see what are the other two parameters. One is the flow rate, which is the number of vehicles in a given time interval by the time interval. And it is also related to the time headway as if we denote it as h. So these two are reciprocal relations. So this summarizes all the fundamental relationships. Now there is a, so this is basically everything. So these are if I relationship between macroscopic and microscopic characteristics. So the time average speed is, sorry, space average speed is the harmonic mean, which is n divided by summation I equal to 1 to n vi. Space, so time average speed is 1 by n is the arithmetic mean vi, I going from 1 to n. So this is at a given x, this is at a given time. So these are spot speeds, which are microscopic characteristics, and the left-hand side is macroscopic characteristics. Similarly, how is the flow rate given? Flow rate is the inverse of average time headway. And what is that? It is nothing but n by summation of all headways. And what is density? Density is related as 1 by the average spacing. So left-hand side, it is this is the definition. So Q is n by t, nt by t, and here it is nx by x. And the average spacing is the number of vehicles in that divided by equal to 1 to nx spacing between two successive vehicles. These are all the relationships. The next part is next thing is to relate these three among themselves. So these three are the key parameters: the space mean speed, the flow rate, and the density. Now these three are related by another relationship as the flow rate is equal to k times Vs. So this is the we have seen the relationship between macroscopic and microscopic quantities, and this is the relationship between macroscopic quantities. Right? So how do we prove it? So you take a given stretch of the road. Suppose this is x equal to x1 to this is x equal to x2. And there are vehicles everywhere in between. What is the space mean speed? Space mean speed is x by some time interval t. So if there are n number of vehicles, it will be nx by nt, right? So the space mean speed Vs is nothing but x by t, right? So if you take an ith vehicle and it travels the entire distance in a time ti, it is summation x by ti. Now you replace, so instead of taking the individual vehicles, the total, what will be the total distance traveled by all the vehicles? If there are n number of vehicles in the road, it is in that road stretch, it is nx by what is the time taken for each of them? It is ti, and you just summation over all ti's. So it is nx by summation of all ti. And what is the summation of all the time taken for all? It is nothing but the, so this is the sum of all time intervals is nothing but the total time of observation t. So you have n This is the total length divided by t. Now, what is the total number of vehicles in the given stretch? It is the density times uh, mm, sorry. So instead, let us consider a unit. So suppose you have a unit stretch x, and there are n number of vehicles in the stretch. The total distance, so in a given time interval, and n number of vehicles will be traveling through that. This is the total interval, and the density is n by x. Now, if you take the ratio of q to k, so if you take q by k, what is it equal to? Is n by t divided by n by x. This is nothing but x by t. But what is x by t? Here t is the total time taken by so if there are n vehicles in the stretch, it is the time taken by n vehicles to cross this point. So that is the total time, which is the total time of travel of all vehicles. And x is what? X is the uh, you have x is the total distance. So this is nothing but the space mean speed. Therefore, you just rearrange, you get q is equal to k times vs. So this is one macroscopic parameter. This follows directly from the definitions. But there are also traffic stream models which relate the density to speed. So we have related the microscopic to macroscopic parameters. We have related the macroscopic parameters among themselves, which is given as q is equal to k times the space mean speed. The others have to be actually determined by some empirical model. So one thing that we have is called the green shield. So green shield's macroscopic model. What is it? In that they assume that as the density increases, so here on the x-axis we have the density, and in the y-axis we have the space mean speed. So if the density is 0, if the road is fully free or there are just one or two vehicles, you can go at full speed. And as density increases, the velocity, the space mean speed will decrease. And at some point, the vehicle will become jammed. So this is called the jam density, where the space mean speed vanishes. And this is called the free flow speed, where the speed is maximum at density is 0. So when you approximate this relationship by a straight line, we have what is called the green shield macroscopic model. It can be any model. It can be parabolic. It can be logarithmic, which result in other models. But the simplest one is the green shield model, which is it's a part of your heat syllabus. Now, when we fix this, we can fix the other relationships. How? So Q is equal to k times b. So the relationship between Q and V is something like this. So when there are very few vehicles, so when density is, let me put it the other way, let me put K versus Q. So when there are very few vehicles, the speed will be maximum, but the flow rate is measured as n by t, right? So when there are very few vehicles, the flow rate will be 0. And when there are very large vehicles, so this is K jam. At jam density, the velocity is 0. So if you fix the given point where you're measuring the flow rate, no vehicle will cross the point because all vehicles are at rest. Somewhere in between, it reaches a maximum, which is called the maximum flow rate. This is called the maximum flow rate for a given. And you can also draw the graph between the space mean speed and the density. So again, when the space mean speed is 0, you have the flow rate will be 0, because when the space mean speed is 0, it means it is a jam density, nothing is moving. So at a vehicle, if you fix the point where you're measuring the flow rate, no vehicle will cross that. So it is 0. And at free flow speed, again, we know there are free flow speed is achieved only when the density is 0. So which means there are no vehicles, there are very few vehicles. So the flow rate is 0. And this achieves a maximum somewhere here. So this is the V free flow. This is the jam density. And somewhere in between we have Qmax. So based on this, we'll look at some simple problem in the thing. So if you take let us take this problem, right? It is simple. So consider the 4 points P, Q, R, and S shown in the green shield fundamental speed flow diagram. So this is S, R, Q, and P. And the corresponding densities are given by Kp, Kq, Kr, and Ks. What is the order of these densities? We know that K is Kv is equal to Q. So K is equal to Q by V. So what does it mean if you draw V versus Q? The slope of that line is the density. But what we have is V versus Q. What we have is V versus Q. So reciprocal of the slope is density. So it is like 1 by K. Now what should we do? It is very simple. So what is the slope at the point P? It is kind of 0. Let's consider the next case. So at the point Q, you can draw the average. So this is, so what is Q by V here? So this is 1, this is KQ. Right, we are taking Q by V is the slope. So this line is, so here it is QQ and this is VQ. So using similar triangles, you know, Q by V is, this is like 1 by KQ. And here this is 1 by KR. And here KS is infinity. Kind of something like infinity. So what is the order? So this is the largest KQ and here it is like 0, right? It is flat. So here it is flat, here it is infinity. So here KP is something very small. KQ is, KP is something very large. The slope is 0, so 1 by the slope is infinity. So here it is some large number, here it is something smaller, and here it is, so here 1 by Ks tends to infinity, so Ks is 0. So the correct order is Kp greater than Kq greater than Kr greater than Ks. So that is it. I think we are out of time. Maybe we'll look at just 2 more problems and close the session. So that's a simple problem. I hope it is clear. Now, this is one problem which appeared in GATE 2023. So a plot of the speed density relationship for 2 roads is shown. So in the first case, what is the relationship? You know, this is the this is the free flow speed. This is the jam density of road A. This is the free flow speed and jam density of road B. What is the equation of these two straight lines for line A? For road A, what is the equation of the straight line? These are the intercepts, right? So you know x by a plus y by b equal to 1. So u by ua plus k by ka is equal to 1. And for b, it is u by ub plus k by kb is equal to 1. Now you can rearrange this so that you get so I can rearrange this so that you get u is equal to uda times 1 minus k by ka. And for this, you get u is equal to ub times 1 minus k by kb. What is the flow rate? It is k times v. So for road A, it is K times UA into 1 minus K by K. So it is nothing but UA into 1 K minus K square by K. And what is it for road B? It is K times UB into 1 minus. So it is K times V, right? So I'm just multiplying the density with the expression for velocity. So it is UB times K by KB, which is UB into K minus K square by KB. So this A and B, there's nothing very different between these two expressions. You just have, you'll do for A, and then replace everything for B. Now let us find out, we are asked to find out the capacity. So if the capacity of road A is CA and capacity of road B is CB, what is capacity? Capacity is the maximum flow a road can take. So capacity is the maximum flow. It's just English, right? That is very nothing. What is flow? It is Q. So how do you find what is Q max? Find, so you just, yes?
Differentiate and equal to 0, sir.
Yes, correct. So differentiate with respect to what? Differentiate with respect to something and set it equal to 0. Now we have got that Q is equal to, for a given road, it is the free flow speed multiplied by K minus K by K square by K jam density is the free flow speed. So this is UF is a given number, Kj is a given number, so it is a function only of K. So differentiate with respect to K and set it equal to 0. So if we do that, dq by dk is equal to, we have UF, this is 1 minus 2k by k jam is equal to 0. So what is the maximum, the density corresponding to maximum flow rate? It is kj by 2. So the maximum flow occurs at half of the jam density. If you assume green shield model, if you assume there is a linear relationship between U and K, then the maximum flow happens at half of it. Now just substitute everything back. So what is Q? Q is equal to the free flow speed multiplied by, this is K jam by 2 minus, this is K jam by 2 the whole square divided by K jam. So this will be 1 by 4. 1 by 2 minus 1 by 4 is UF into K jam by 4. So the capacity Q max is the product of the free flow speed and jam density. So the capacity of road A is what? It is UA, which is the free flow speed of road A, multiplied by jam density of road A by 4. Capacity of road B is UB KB by 4. And what is that? What are they asking? They are asking CA by CB. So CA by CB is UA KA by UB KB. So the correct answer is UA KA by UB KB. Again, most of the time, you can remember this formula. If you have a linear relationship, K max will happen at jam density by 2, and the capacity is free flow speed multiplied by jam density by 4. So these two you can use it for multiple questions. Let us see if there is any other related to the same concept. So yeah, so this is based on the same concept. It appeared in 2018. So it is given that the space mean speed and the density are linearly related. So green shield model works. So you have a free flow speed and you have a jam density K jam. They are linearly related. Done. So if they are linearly related, what did we just derive? We know that the maximum flow is VF Kj by 4. So let us remember this formula. We just derived it. The free flow speed and jam density are 80 and 100 vehicles per kilometer respectively. The traffic flow corresponding to a speed of 40 kilometers per hour is what? Okay, so it is given that the free flow speed is 80 kilometers per hour and the jam density is 100 vehicles per kilometer. Always note that these two have to be in the same units before you do any computation. Otherwise, it becomes problematic. And what is the function we got? What is the function we got in the previous question? Q is equal to UF into K minus K square by K jam. So just substitute here. U is equal to what is the free flow speed? UF into K minus K square by K jam. Now UF is 80. K is given as okay. We are asked to find out corresponding to K, right? So so let us no problem. So between K and V, we have a linear relationship. So the jam, so the free flow speed is 80. The jam density is 100. Sorry, the jam density is 100. And we need to find out what is it for a value of 40. So this is a triangle, and you can use similar triangles. So this is half of this, right? So if the ratio of this to this should be equal to the ratio of this by this, right? This angle is the same. These are similar triangles. So V by VF is equal to 1 by 2, which means this is K by Kg. By similar triangles, that is also equal to 1 by 2. Therefore, K is equal to 50. So it's actually at the optimal value. We are at K jam by 2. So directly you can substitute in this formula, no problem. You can also substitute here. So corresponding to a vehicle, the space mean speed of 40 km/h, the jam density is 50. Sorry, not jam density. The density is 50. Jam density is 100. So into 50 minus 50 squared by 100. So just substitute and find out what this value is. So 50 squared by 100 is 25. So 50 minus 25 is 25. 25 into 80 is 2000. 2000 watt, the units are. So this is in vehicles. This is in kilometer per hour. This entire quantity is in vehicles per kilometer. So kilometer gets cancelled and you get something in vehicles per hour. And the value is 2000. Yeah, so we are too much beyond the time. I'll stop here. The other questions are simple. You can look at it. Yeah, I'll stop here. If there are any doubts, you can ask.
Thank you, sir.
Okay. We'll end the session. So I hope it is. Yes. Yes.
Thank you, sir.
Okay. So we'll end the session. So we'll go by the plan. We can stop the recording. We'll go by the plan.